Hello, welcome to the semantic analysis series of natural language processing. Imagine that you are hungry and you type best biryani near me, and boom, in less than a second, Google shows you a ranked list of restaurants. That's faster than you deciding between tea or coffee, isn't it? And the magic behind this, it's called information retrieval. Today, let's explore how machines find what we want from the sea of the data. So, information retrieval or IR is simply the science of searching and finding relevant information from huge collection of data. And as you can see on this slide, think of it as the Google of Google. How does Google find answers in just 0.31 seconds? It doesn't create information. Google doesn't create information. It finds the right piece for you. While databases deal with structured rows and columns, IR shines in the messy, unstructured world of text or web pages or documents even. So let's see some everyday examples of IR. Dear friends, IR is everywhere. Google and Bing for the web, Netflix when you are searching for your next binge, then Amazon when you are hunting for the perfect phone case, or Spotify when you want songs that match your mood, isn't it? Even your research on the PubMed or IEEE runs on information retrieval, and we use daily without realizing how much work happens behind the scenes. So, how does information retrieval actually work? There is the simple flow. You can see on the slide, you enter a query, the system checks an index like the back of the book. It retrieves possible matches and then ranks them based on relevance and finally shows you the results. Simple to use, but incredibly complex under the hood, okay, as it appears. So, indexing is the heart of the information retrieval. Instead of searching the entire web every time, information retrieval systems pre-build an index. Imagine a dictionary where each word points to the pages where it appears. And that's what an inverted index does, but on web scale. Billions of documents are all connected to the words inside them. So the core IR process involves user query, which is typed in natural language, indexing the document which are pre-organized, retrieval of matching query to the documents, ranking which sort inserts or results by relevance, presentation show to the user. Okay, so indexing is the search engine's brain. Now, not all results are equally awful or useful, sorry. That's why ranking matters. Early systems used TF-IDF, term frequency, which we have referred in last unit, which scores how important a word is. Then came BM25, which is a smarter version, and today artificial intelligence powered model like BERT understand the context. And that's why if you type apple, your results differ depending on whatever you have been browsing, iPhones or apple pie recipes. It gives you the relevant results. Okay, so there are different challenges. This process is not that easy. There are certainly some challenges involved. So people type weird queries many times. There are typos like restaurant instead of restaurant, restaurant instead of restaurant. Words mean different things. Bat could be cricket equipment or a flying mammal. And then there is multilingual search, which is someone searching in Hindi, someone searching in English, and so maybe someone in other language. So solving this is what makes information retrieval a challenging and exciting field. Let's consider the difference between IR and NLP because we have been discussing natural language processing through and through this season. So it a natural question comes in our mind that how information retrieval is exactly different than natural language processing. So here is a key point. Information retrieval is about finding documents, and natural language processing is about understanding meaning. When you combine them, you get next level tools. For example, semantic search doesn't just match words, it understands the intent. And that's why IR plus NLP is so powerful together. You can just imagine. And our aim is to integrate IR with NLP. So if you're wondering how to try this yourself, there are some great tools. Whoosh in Python, you can see for small scale IR, then Elasticsearch and Apache Sol R for enterprise level search. Then you have Gensim for topic modeling and similarity. And for cutting edge Hugging Face transformers, let you build semantic search engines. Cloud platforms like Azure Cognitive Search or Google Vertex or AI makes it even easier. Okay, so these are all tools that we just referred to: Whoosh, Elasticsearch, Solar, Gensim for topic modeling, Hugging Face, and Cloud Vertex AI search. When it comes to real applications, it's endless. Search engines, obviously, but also voice assistants are there nowadays, like Siri or Alexa. They retrieve before they respond. Legal and medical industries use information retrieval to sift through case laws or patient histories. Then we have recommendation engines like YouTube or Netflix. They are powered by retrieval plus personalization. So everywhere you look, IR is working silently behind the scenes. Future of IR, if we consider, then it's even more fascinating. We are moving towards semantic search, where machines get meanings, not just keywords. Multimodal IR is already happening. Search with an image or even a voice clip. Then there is personalized search, which adapts to you, and soon conversational search, where instead of typing queries, you will just chat with a search engine. So it's time to wrap up. Information retrieval is the backbone of how we interact with the digital world. Before AI can understand, it has to find. That little search box we take for granted is one of the most powerful tools in technology. So, next time you search for something, remember behind that tiny box is a universe of algorithms working for you. So, that's all for today for information retrieval. Please write your comments in the comment box and give feedback. Thank you.